This is the first section about programming basics, which is an introduction to all of the theory that you need to know for your programming. When you're doing any sort of computer programming, you're going to have variables. Now, these are used for most programs that you will be working on. The definition of a variable is basically it's a named value where it has a designated section of memory. Now, variables can change during the program's actual running. You're going to use variables for parts of the program that you need to assign values to, and that's what we're going to look at with these data types. The definition of a data type is it's the format in which you store your variable or a constant. For example, a whole number, which is an integer, a string of text, or a single character. So you've got to think about why you would actually use a data type. And this will become a little bit more clear when you start seeing some examples, but we basically use the correct data type because it makes your code more memory efficient. If you know how much memory you need to use, then it's going to be more efficient rather than just use the set amount of memory for each one. It also makes your program a little bit more robust. It makes it less likely to break, and also it makes it more predictable for the computer so it can understand what's happening. If you've never seen the word robust before, if you just check the bottom, basically says that robust means sturdy, reliable, and hard to break. So in programming, this means that the program is less likely to crash. So there are 5 main data types that we need to know for this course. Programming languages store the data in these 5 different types when you're doing your programming. So if you look at this table, we've got 5 main data types: integer, real, Boolean, character, and string. In the second column along, we've put the pseudocode in. So the pseudocode is basically, you can write this as a little abbreviation and it works for basically any programming language that you're going to use. Your pseudocode is your planning and your design for it, so that will be recognized by examiners. Your characteristics, so this is a description of what you would use those data types for. So integer, you've probably done this in maths at some point, but an integer is a whole number. A real or a float is a number that's got a decimal point at some point in the number. A Boolean is either true or false, yes or no, 1 or 0, so something that's only got 2 values. A character is any single letter, number, or symbol that forms into your character set. So if it's ASCII, for example, there's 128 possible characters that you could have. So it's all the alphabet in lowercase, all the alphabet in uppercase, anything like exclamation mark, question mark, hash, all of those things are characters. And a string is usually used to represent text. So this is a collection of characters. So anything like a sentence or a full word is a string. So take a little minute to think about what you could put in the examples column there. So for an integer, what could you think of as an example? For a real, what's a possible example? And if you work out through that table and plan in your head what they could actually be, it'll start your brain thinking of what these data types are used for. You might want to pause the video at this point so you can have a think. So here's some possible examples for the 5 different data types. This should really cement the understanding of what these are used for into your head by now. So first of all, integer. This has got to be a whole number. Now that can include the number 0, it could be number 6, it could be 10,253, or even a negative number like -999. Anything that is a whole number with no decimal points can be stored as an integer. A real or a float is anything that is got a decimal point in, so any decimal number, 0.15, -5.87, 100.0. A Boolean has got 2 different options, so it's used for true or false, 1 or 0, yes or no. Character could be A, B, C, D, any sort of single letter, uppercase, lowercase, numbers or characters. A string could be any group of characters, so any word or anything that's got symbols as part of a sentence. So if we go a little bit more in depth into why we use data types, it's basically to do with making your memory more efficient. So if we take a little second and look at how much space is used for the different data types, it might make a bit more sense. So for an integer, if you think about how much memory is used on average for a number, it's usually 2 bytes or 4 bytes of memory that's being used. If you use a really small number, so if the number is, say, for example, the number 2, then you're only going to use 2 bits to make that number. So 2 in binary is 10, so you're only using 2 bits of memory. There's no point in reserving a big chunk of memory if you're only going to use up 2 bits. This is why we use an integer instead of using a string. Another reason why we might use an integer is because you want to make some sort of calculation, like add 2 numbers together. No, you can't add 2 strings together. All that will do is stick the 2 strings next to each other. It won't actually do a mathematical addition. So for a real or a float, we need a little bit more space because we need memory for what's after the decimal point as well. A Boolean is one of the most memory efficient things you can do because you only need 1 bit. It's either a 1 or a 0. So if you can set variables to true or false, that's the most memory efficient thing that you can do because you're only going to take up 1 bit of space. A character is 1 byte that gets used, and that could be bigger if you are using a different character set, but just in the ASCII character set we use 1 byte. So that's 8 bits of data. This is because there are 128 different characters, so we need all those different possibilities. A string is 1 byte for every character that's in the string. So obviously if you're going to write a big long sentence, you're going to need a lot of bytes of information. Sometimes during programming, we need to take one variable or one particular piece of data that is in a data type, and we need to change it into another one. Now this process is called casting. So a lot of languages already have inbuilt functions that allow you to do this. So for example, we can convert a string to an integer or an integer to a decimal. This line of code at the bottom is Python code. You are asking the user to input their age, so you're asking them to input what is your age. They will type in a number. Now when they first type that number in, it is numbers that they're typing, but it's going to come in string format. Now if we use casting and convert it to an integer, that will allow us to, 1, save a little bit of space, but also 2, we can then do something with that number. So if you wanted to add 2 ages together, for example, or do some sort of calculation, you won't be able to do it when it's a string. You would need to convert it to an integer so we can actually do something with the numbers. So it's time to put your brain to use again. If you think about casting and you look at these small little casting functions that are in the red boxes, think about what that actual thing is going to do. So we've just looked at age, for example. If somebody typed in their age as 23, int 23 is going to convert the string 23 into the number or integer 23. So pause the video, think about the functions, the casting word that is before the brackets. What is it doing to what is in the brackets? What is it? Describe the actual process that's going on. So if we take a look at the answers, first of all, integer with 99 in as a string, so inside the speech marks, it's converting the string 99 to an integer. Float 1 is going to convert the number or integer 1 to the decimal 1.0. Bool 1 converts the integer 1 to the Boolean value true. The string of true converts the Boolean value true to the string true. ASCB is the one that you probably were a little bit stuck on. This takes the character or thing that's in between the speech marks, B, it converts it to the ASCII number 98. Now you don't need to remember all of the ASCII numbers, so even if you'd have just said it's going to convert it to ASCII, that would be fine. But it's converting the lowercase b to what its ASCII corresponding value is. In this case, it's 98. The one next to it does the reverse. So you're taking the ASCII number 98 and converting it to a character. These are all different functions that you could use casting for to convert one variable to another data type. When we're thinking about data types, sometimes you might need to output a number of different variables all in one particular line of code. So one useful thing that we can do to put all of these multiple values together is concatenation. Now this is basically a fancy word for putting things together. So for example, you might have someone's first name and second name and you want to join it together into one output. So you could use something called concatenation, which will allow you to join these values together. The string casting function will be really useful for this because then you can output text to the screen. So a little bit of further explanation. The definition is basically concatenation is joining more than one string together. This is often done using the plus operator. So as a little example Python code, we've got string 1 equals my favorite actor is. String 2 equals Arnold Schwarzenegger. So we've got two strings of data. We're going to create a third variable called final output, and we can say string 1 plus string 2. Now if we print out final output, it's going to merge those two fields together. Now actually that would basically stick them together so that your colon would be followed immediately by the capital A. So to make it into a proper sentence, we want to add a space in the middle. So just by adding two speech marks and a space, that will create a space in the middle. You could do the same with a dash or a comma or anything else that you want to do, and it will help you to create a big string of text. Thanks for taking the time to watch this video. Please hit like and subscribe.